Alright, so let's take a look at these now. Again, as we know, the first step on these problems is always find the parent alkane. And in this molecule, we can find that along this path. And that gives us a total of 6 carbons. So 6 carbons is hexane. But because we have an alkene here, it becomes hexene. Now, which way do we need to number this one? If we start on the left side, we get our alkene at 3. If we start on the right side, we also get our alkene on 3. Now remember, when the alkene gets the same number in both directions, how do we break the tie? Well, we break that tie then by looking at substituents as if there was no alkene. And so if we need to do that, then we're going to end up starting on the right side and numbering to the left. Because going this way gives us a substituent on 2, whereas starting on the left side, our first substituent would be on 3. So if we name our substituents, we've got a methyl at 2. 3 gives us an ethyl. And 4 gives us a bromine. And remembering that the alkene is on 3. So putting those alphabetically, we get 4 bromo, 3 ethyl, 2 methyl, hex 3-ene. Are we done? Almost. But what else do we need to do? Need to do E and Z. So if we look at our alkene, on the left side of the alkene we have a bromine versus an ethyl. The bromine is going to be higher priority. On the right side of the alkene we have a carbon bonded to 2 carbons compared to a carbon bonded to 1 carbon. Carbon being bonded to 2 carbons is higher priority. We can see our higher priority groups are on the same side, and that means our alkene here is Z. Alright, now as we go on to these others, we're going to see they get more complicated. There's more going on. But it's always the same sequence of steps that we take in order to do these. So what's that first step? Well, just like always, find the parent alkane. And we can see it goes there. How many carbons? 9 carbons, so this is going to be related to nonane. Now, which way do we number it? Well, unlike the last example, this one there's no ambiguity at all. If we start on the left side, we have to go to our 3rd carbon before we find an alkene. But if we start on the right side, there's an alkene right away on that 1st carbon. And so immediately we know we're going to go right to left. All right, next thing, let's name all of those substituents. Now to do that, that first substituent we find at number 3, that's something we haven't seen before. But based on what we've learned, we should be able to figure out what to do here. So normally, if we have a 3-carbon substituent, 3 carbons we know is propane, and so 3 carbons as a substituent gets named as propyl. Well, what we have here at carbon 3 is a cyclic substituent, cyclopropane. So what would be logical to call cyclopropane when it's a substituent? How about cyclopropyl? So just like any other type of substituent. From here, the rest of these are pretty easy. 4-ethyl, 5-methyl, 6-isopropyl, 7-methyl, and 8-bromo. So now we can alphabetize those, starting with 8-bromo. When it comes to cyclopropyl, where are we going to alphabetize that? Well, the key there is that cyclo is not a numerical prefix. So that gets alphabetized under C. So cyclopropyl, bromo, then we've got ethyl, then isopropyl, and then our 2 methyls, 5,7-dimethyl, and we've run out of room on this line, but we've got 3 alkenes in this molecule. So this becomes nona, and those alkenes are at 1, 3, and 6, and because there's 3 of them, then we say triene. Are we done? Not yet. Now we have to do EZ and RS. So let's start at carbon 1. So the alkene at carbon 1 has 2 identical substituents on one side. So E and Z don't apply. Let's just erase all of this so we can work with it better. The next alkene on the left side, the higher priority is the carbon to the top. Why? That's a carbon bonded to 2 carbons versus at the bottom is a carbon bonded to 1 carbon. What about the other part? So if we start here, this is a carbon that's bonded to 2 carbons. We also count the double bond as being bonded to 2 carbons. So we're going to have to go one further. When we go one further, we get to these carbons, which are bonded to more carbons than the end of the chain is. So our top priority is here. Those are on the same side. So this carbon, or this alkene, the one at 3, is going to be Z. Now, what's the next thing that we have to look at? It's not an alkene, it's a chiral center, the one here at 5. So the hydrogen is not drawn in. We know that's 4. The methyl here is going to be 3. Now, the 2 remaining groups, the initial carbon that's attached to the chiral center is a carbon with a double bond and a single bond. So from there, we've got to keep going. If we go to the other end of the double bond, again, it's bonded to 2 carbons. But the other way is an isopropyl versus an ethyl. And we know that isopropyl gets higher priority, so 1 here, 2 here, arrow goes clockwise, we have 5s. Again, let's just go back through a little bit of that. So when we're trying to compare this carbon to this carbon. Our initial look at it shows that this is a carbon with a double bond and a single bond, and that's the same on both sides. If we go up, this is a carbon that's bonded to two carbons. Same thing here, the other end of the double bond is bonded to two carbons. But when we go down, this carbon is bonded to two carbons, whereas that's only bonded to one carbon. So that's our point of difference, and why we assign priority the way that we did. All right, need to keep going. The next alkene, again, we need to assign E or Z. And we should get Z for that one, 6Z. And why do we get Z? Well, on the right side, if we go down, we have a carbon bonded to two carbons. Going up, though, we have a carbon bonded to two carbons. So far those are the same. But when we went up, if we go past that, we're dealing with a bunch of methyl groups with the exception of this part of the chain here. So higher priority here. The other side of the alkene is pretty straightforward. It's a methyl versus a carbon with other things on it. Higher priority here. On the same side gives us Z. Alright, we're almost done. Last, we have to do this stereocenter on carbon 8. So the bromine is, of course, first priority. This is second priority, and the methyl is third. Our arrow goes clockwise, which is R, but we take the opposite here because our lowest priority group, the hydrogen, is pointing forward, which gives us S. So finally, we have the full name of this compound, 3Z, 5S, 6Z, 8S, 8-bromo, 3-cyclopropyl, 4-ethyl, 6-isopropyl, 5,7-dimethyl, nona 1,3,6-triene. Seems like a lot, and there is a lot going on in that problem. But again, it helps us to reiterate that with nomenclature, no matter how complicated the example looks, we're still just taking those same steps we've learned and using them over and over and over again. As we move on to number 3, we're going to do the same thing. So our straight chain here, longest chain, goes right down the middle. And we can see with the alkene at one end, we need to go left to right. So this is again going to be nonane. And more specifically, nona 1,3,5-triene. Now we can name our substituents. We've got a whole bunch of methyls. They're at 2, 3, 4, 7, and 8. We have a cyclopentyl, a 5-membered ring, at 5. 7 also has a chlorine, and 8 has an iodine. So now we need to put all of these in alphabetical order. So what comes first? 8-bromo, then 7-chloro, followed by 5-cyclopentyl, 8-iodo, and then all those methyls. There's 5 of them. So that becomes pentamethyl nona 1,3,6 triene. That's not too bad. Are we done? Not yet. We still have our EZ and RS. This one's not quite as bad as the last one. Why? Well, we only have two alkenes we have to look at, which are this one and this one. And we only have one chiral center, which is this one. This center here is not chiral. And the reason that it's not chiral is notice that two of the substituents, that one and that one, are both methyls. If they're both methyls, that means they're the same, and that center is not chiral. We also have this alkene, which has two hydrogens on one side. So remember, if there's two substituents the same on one side, E and Z don't apply. So we only have two alkenes to assign along with one chiral center. So let's just do this. So we should have something for 3, for 5, and for 7. So the alkene at 3, on both sides we have a methyl versus a larger carbon group. Higher priority, opposite sides, 3E. At 5, one side of 5 is very easy. We have a hydrogen versus this carbon group. So higher priority down here. What about the other side? Well, this is a carbon bonded to 2 carbons. This is a carbon that counts as being bonded to 3 carbons. That's higher priority. Higher priority groups are on opposite sides. We have 5E. And then we just need to do our chiral center. Highest priority is the chlorine. Then to the right we have a carbon bonded to iodine. To the left we have a carbon bonded to other carbons. Carbon being bonded to iodine, higher priority than other carbons, higher priority than methyl. So the lowest priority here is a methyl group. For once it's not a hydrogen. That doesn't change anything. Just means that we need that methyl, which is our lowest priority, to be pointed away. It already is. We draw in our arrow, and so we have 7S. Alright, one last example, number 4. Again, we've made the longest chain relatively easy to find, goes right down the middle. 7 carbons for heptane. Which way do we number it? Well, we're going to go left to right because that gives the alkene a lower number, 3 as opposed to 4. So this is going to be hept 3-ene. Now we can name our substituents, and we'll just do that in alphabetical order. 5-bromo, 6-chloro, 1-iodo, 2-methyl. Final step is we need our EZ and RS. And we have chiral centers at 2. We have the alkene at 3. Chiral center at 5. Chiral center at 6. So the alkene is probably the easiest one in this molecule to do. We can see that that's a transalkene, and that means that by default it's going to be E. At carbon 5, we have a bromine, which is highest priority, followed by the carbon with the chlorine and the carbon with the double bond. Goes counterclockwise is 5s. The carbon with the chlorine is first priority. The carbon with the bromine is second. The methyl is third. That's counterclockwise, which is S. But because the lowest priority group, the hydrogen, points forward, we take the opposite. So that's 6R. And finally, at carbon 2, we have a methyl, which is going to be third priority. The alkene is second, and the carbon with the iodine, because iodine is higher atomic number than carbon, is first. Goes counterclockwise, and we have 2s. So some complicated examples, but again, it's all of the same steps that we've learned, that we've been using over and over again. When you get one of these complicated examples like this, the real key to doing these and doing them well is to break them down and just go one step at a time. Don't get overwhelmed by the fact that there's 10 substituents or there's 3 stereocenters. Go through your steps. Find the parent chain. Figure out which direction to number it. Name your substituents. Find your R and S. Find your E and Z. And if you do those just one at a time, even these really long, complex examples won't seem quite so bad.